Hello, Yawning Angel, back again, back with another AMOS video, and in this one we're going to be taking a look at sprite animation. What? Sprites again? How come? Because we wanted to look at sprite animation and how to detect collisions between sprites. Fine, but will we get back to Bob's somewhen? Yeah, I guess we will at some point, yeah. Okay. This is good. Yes, what we're going to do in this video, we're going to get sprites to animate. And what we're going to need is the program that we wrote in the last video. So the link to that video is up here, and the code for that video is available for download on my website. And if you follow the link down here, go to my downloads page, and you need to look for Working with Sprites Again. Download that code. There's the AMOS file, and there's a .txt version of that file there as well. What we're going to do is use that program and build on it to get sprites animated and get those collisions detected between sprites. This is really exciting. We're really making progress. So without further ado, let's crack on with it. Right. Okay, here we are in the code. Before we start, mouthful of tea. Maybe 2 mouthfuls. Need a cup of tea before I start coding. Right, so the program code I've got up here, this is a version of the code that we used in the last video. Once again, you need to go to my downloads page and look for the program code for More Working with Sprites. Download that and you can build on that, which is what I'm doing in this version. Or you can just wait until I've finished coding this and you can go to my website and just download this code. It's up to you. Right, so what I've done with this code, I've put some annotations in as to the kind of thing that I want to be doing in here, the changes that we need to make. And we're not really changing much, we're actually adding quite a bit. So let's crack on with it. So the first screen then, we're opening our screen, we're setting our sprite buffer, we are loading in our sprites image bank. Once again, you can download that from my website as well. We get our sprite palette, we clear the screen, we turn hide on, which should hide our mouse pointer. We're then going to assign our colors from 0 to 15 to position 16 to 31 in memory for the sprite color palette. That was covered in the last video. Then we're going to get our sprites and assign them to, well, we're going to get our images from the image bank and assign them to sprites and assign those sprites to channels. Channels really important, and we looked at this last time, and we're going to be using channels again in this video. It really is paramount to the whole AMOS animation language routines, the AMAL code. We're then going to make a mask around those sprites. And here's the first part of our new code. We're going to position a random sprite on the screen. Okay. Before I do dive into that though, what I'm going to do is just hit F1. I'm going to run this code because this code still runs. This is the code from last time. So if I move my joystick, I've got control of that character there, and that is my player character. And that's all it does at the moment. It doesn't do anything else. And I press the fire button to exit, and we're back to the program. Right, so we are going to put a random sprite on the screen. That'll be the next thing. Then we're going to turn on our movement. Then we're going to activate player sprite animation, which is going to be exciting. Then there's just the usual, our main routine, which will handle our joystick input. But here we're going to put a new piece of code in. We're going to set up and manage a score. Yes, we are turning this into a game. Oh, this is exciting. So we're going to manage a score there. The rest of this code is still the same. We're controlling managing our joystick here, left, right, up, down. And then we've got some new code in this do loop. We're going to check for sprite collision on our target, which is sprite 10. Ooh, exciting. Bit of code in there. That's just our existing routine here, the CAssign. And here's our new procedure, place sprite at a random position. And I think that is it. And there's some erroneous code down the bottom there, which you shouldn't see, but don't worry about that. We'll ignore that for now. Well done, Yawning Angel. You've left some old code in there. That will not appear in the final version of this program. Right, so without further ado then, let's dive in. So let's go back to the top. So if you press Control and up, you'll shuttle through the code a little bit quicker, and the same if you do control and down. It saves going down the line at a time. So let's get to this bit here. We're going to put a target sprite at a random position. So to do that, we are going to call a procedure called rand_sprite. Okay, and AMOS capitalizes that, of course. So let's go down to the bottom of the code and write that routine. Right, we shuttle to the bottom of the program where I've now tidied things up. Right, so let's get our procedure written then. And this is quite straightforward. It is just a procedure to position a sprite randomly on the screen. So procedure rand_sprite. And just for good coding practices, we'll put the end proc on there as well. So that's all nice and tidy. So what we're going to do for this sprite, we're going to take a sprite and just dump it in a random position on the screen. Okay, but we want that sprite to be animated. So what we're going to do first is rem deal with sprite animation. And we're going to use the command anim. And the command goes like this. Anim is the animation instruction for AMOS. And the first parameter that goes after anim is the channel number. So we've already got 3 sprites we know of. We've assigned them to channel 1, channel 2, and channel 3. So we're going to animate the sprite in channel 2. So channel 2, okay? And the next bit, you need to put in speech quotation marks, okay, because this is part of the AMAL language instruction set. So we open our quotations there, we then have a bracket, and what we're going to do, in these brackets, we give it 2 parameters, 2 values go in here. So the first value is the image number. So this will be the image number from the image bank. So it's image number 3 in this case. Don't worry if you're a little bit confused, this will become clearer as we move on. We're then going to give it a time that it needs to animate for, and this is measured in 50ths, 1/50th of a second. Okay, I need another mouthful of tea. Getting a bit of a hoarse throat. Right, so I'm going to set this to 10 1/50ths of a second. How do I know this? Basically because trial and error, and I've just experimented to see what works, and this works best. We can then give it another animation frame. So that first one, this is our first animation frame, and we're now going to give it its second animation frame, because if you remember in the last video, I have got 2 versions of each sprite, and when you toggle between them very quickly, it gives animation. So the next image I'm going to use is image number 4, and I'm going to animate that for a 1/10th of a 50th of a second. Does that make sense? So that goes there. I close off that bracket. Now I want this animation to keep repeating. And what we have to do for it to keep repeating, we have to put in the letter L. I guess this stands for loop. But this will tell the program just to keep this animation going. Keep it going. It's a bit like, I suppose, a modern day GIF, isn't it? It just keeps looping. This is what this is going to do. So with that done, now I need to turn animation on. So anim on, and I need to turn it on for this channel only. So what I'm doing here is switching on anim on channel 2. Okay, this tells the program, right, you've got this animation defined for channel 2. It's image 3 and image 4, and you're looping it. But it's off by default, so I need to turn it on. I need to tell the program, I need you to animate channel 2. I switch the animation on for that, so that will do that. You'll see this in a minute, and it is actually quite cool. So now, let's just F3 that to indent it. So a little bit more code. Now let's actually do the placing. Place a random sprite on the screen. And what I need to do is make sure it is within screen boundaries. Okay, This, for this program, might not be that important, but when we expand this program, this is future-proofing our code. This is quite important. So what I'm going to do here is give a coordinate x1s equals a random number between 0 and 320. Let me move my mouse pointer, it's always in the way of my code. I do apologise. I'm never going to get out of that habit. Okay, so let's just accept it and move on. Then what I need to say here is if x1s is less than equal to 20, let's x1s equal 20, yep, and if let's just F3, that's tight. So what I'm saying here is my x coordinate effectively is going to be a random number between 0 and 320 because that's the width of my screen. If it's less than equal to 20, I want it to equal 20. So I'm kind of giving it a bit of a buffer. Now you might think, well, you're an angel, why don't you just set it to, you know, just control where it's putting it in the first place? You can do that, but I'm doing it this way. So let's enjoy that and move on. So also if x1s is greater than 300, you know what's coming now, don't you? x1s equal 300, and if. Right, so that's our x coordinate. So it's basically going to appear between position 20 and 300 on the horizontal plane. Okay, happy days. Now we need to do the same for y. So we'll have y1s equals a random number between 0 and 200. And you know what's coming now? If y1s is less than equal to 20, we're going to say y1s equals 20, and if y1s is greater equal to 180, we're going to y1s equals 170. And if. Let me tidy that, and there's something I've missed up here. I made a mistake on this line. I do apologise. That should be greater equal to 300. So what we're saying is we're going to put our sprite somewhere on the screen, and it's going to be between, on the x-axis, between position 20 and 300, and on the y-axis it's going to be between 20 and 170. Because we're taking into account the height of the sprite, we don't want, you know, it to position the head in one position and the legs are hanging off the screen or something like that. Yeah, we're giving it a bit of a buffer because we're going to build on this later in another video. Right, now it's the screen coordinates to hardware coordinates in order to position the sprite. So what we want to do here is convert screen coords to hardware coords in order to display. Sprite on screen. Okay, and what we'll do here is x1s is going to equal x hard x1s. Okay, and I'll go through this in a bit, don't worry. y1s is going to equal y hard y1s. So what we're saying here is the value that we've got in x1s, we're going to convert that to a hardware value and store it back into x1s. So our original value of x1s will vanish and it's going to be replaced with a hardware coordinate. Okay, we have covered this before in a previous video, if I recall. So now we're going to put our sprite on the screen, and that's just a case of saying sprite 10, put it at position x1s, y1s, and it's going to be image 3. That's what we're going to put up here. But we've already dealt with that in the channel to say that we're going to animate it. It's going to be images 3 and 4. But for the sake of this, sprite 10, we're going to dump out there, and it's going to be image 3. Our procedure is ended. We'll press F2 to see if there's any errors, and let's press F1. And if we look here, we can see a little bouncing man. So this is our second sprite, our channel 2, and it's been positioned in a random position on the screen, and he's moving. Look at that, he's waving, jumping up and down. Help, come and get me, which is what we're going to do. So that's working okay, and we can move our character around. Obviously there's nothing happening, we've got no collision detection at all, but as you can see, I've got a little animated jumping man. How good is that? Right, fire button to get out of there. So that is our positioning. Let me just tidy this code up a bit. Our positioning of a random sprite on the screen. Let's get on. Right, back at the top part of the code, more tea. Programmers fueled by tea and coffee everywhere. Right, so we've done our random sprite. Now, another bit of code we're going to put in here, we're going to turn on movement, and this is a little bit weird. You might wonder, well, why are we doing this here? I'm doing it here basically to future-proof this program because we may make some changes in the future. So just turn move on, even though we know movement was working previously, so because when I ran the program I could move. So for now, just humour me, let's just leave it there. I might take that out in a future version. The AMOS manual is a little bit ambiguous around the movement instructions, but move on switches on movement, whereas the same way that anim on turns on animation. Okay. Right, now this is the important bit. This is the bit we've all been waiting for. It's the activate player sprite animation. So I kind of jumped ahead earlier, so I do apologize, but let's go through this and let's do a rem statement in here to break this command down. So the anim command break down is like this. So it's anim, anim, and then it's the channel number. Okay, the channel number. Maybe we've got these channel numbers to find up here, 1, 2, and 3. So Sprite 9 is channel 1, Sprite 10 is channel 2, and Sprite 11 is channel 3. Don't forget that. So it's our channel number, and then we do the comma, then we do the bit in quotes, and it's the image from the image bank we want to use, and then the time delay, delay time to image. Okay, and that's in 50ths of a second. And then we'll do another comma, and then we'll have image 2, comma, delay, and then you can have as many images as you like that build up that animation. So, you know, you could have eventually, you could have an image 3, and then you could have image 4. You see where I'm going with this? Yeah, you can keep building on this, and obviously all we're doing is the image 1 and image 2 for this. We're putting in an L to repeat the animation, and then you're just closing off those quotes, and that is it. So you can build up as many animation frames as you like and just put them into this animation command, and it will just run all of them as an animation loop, basically. It's just fantastic. I love it. Right, so let's get that player character working. So animate channel 1, because channel 1 is Sprite 9, and that's our player character. Okay, we're going to animate channel 1, give it a comma, open up our speech, and we're going to do, so that's image 1 for 10th of a second. That's right, isn't it? And oops, no. And then we're going to do image 2 for a 10th, and we're going to animate that and close off our quotes. And then we're just doing a global animation on. So whereas previously I did anim on channel 2, this one I'm just doing a global animation on. It's a little bit messy, it's a little bit Heath Robinson, it's a little bit quick and dirty, but what I want is to kind of set this program up so in the future, when we start to be a little bit more specific about what we're animating and what we're not, the commands are here and we can just change them quickly without having to enter in new commands. So run with me on this, people. We are getting there. Right, so that is basically that main character now handled. So if we now go into our main joystick control routine, we've got a new piece of code here, set up and manage score. We're turning it into a game. How good is this? Right, so what I'm going to do here is we're going to print something on the screen. So locate position 0, 1, and we're going to print target tagged space double quotes semicolon. We've got a variable called score coming in. And then we'll do quotes space times. Okay. So what that's going to do is print on the top of the screen how many times we've tagged our target. You must be able to see what's going on here, surely. We've positioned a random character on the screen, or a character on the screen at a random position, and then we're going to move our character around and try and tag him. Tag, you're it. Yeah, exciting. It is exciting, trust me. Right, so that's that. All this code here stays the same. That's not a problem. Now we come down to this part here. After we've handled our joystick up, joystick down, joystick left, joystick right, and our fire button to exit the program, we've got a new piece of code here. Check for Sprite Collision. Right, let's do it. So what I'm going to do is in here, I'm going to write the code and I'll explain what it does. So I've got a variable called SC, and that is going to be Sprite Col 10. That, ladies and gentlemen, is our Sprite Collision detection code. Just there. And this is why I love AMOS, and I keep saying this every time. It's got all this stuff baked into it, and it's fantastic. Another mouthful of tea. Right. So what we're saying is Sprite Coal will return, I think it returns a 0 or 1 for the detection. So it will return a 1 if Sprite 10 has been collided with. So you put in the sprite that you're going to hit. So our target sprite is Sprite 10. Don't forget, our player is Sprite 9, our target is Sprite 10, and there's a clock one on there as well, which we're not doing anything with in this program, but that will be Sprite 11. But essentially, if we've hit Sprite 10, set the value of SC, I mean, that could be anything, you can have any variable name in there, but SC we're now going to set to 1. So what we're going to do is check. So if SC equals 1, what we're going to do, the first thing we're going to do is increase the score. I'll tidy this code up in a bit, just run with me. So we'll just use the command inc score, okay? And all that's going to do is increase the score by 1. Instead of doing score equals score plus 1, we use the command inc, which will just increase score by 1. It's a much easier way of doing it. Somebody told me about that some time ago, and I do want to thank you for that, and I think that might have been Franco again, so thank you, Franco. Right, so now we're going to place target sprite at a new position. You see what's happening here. So what we're going to do, we're going to collide with our target sprite, and as soon as we've done that, we're going to increase our score, and we're going to move it to another position on the screen. Oh, exciting. And this is why we put the random positioning code in a procedure, because all I have to do now is call rand sprite, that's it, and end if on there, F3 to tidy that code up, and that's what we're doing. Okay, so this piece of code, we check Sprite Collision on 10, we set that value 0 or 1, goes into SC. If it's 1, we're increasing our score, and then we're going to reposition our sprite. So easy, so easy. And I think that is it. Yes, I think that's all the new code there is. So if I go back through here, we've got that new coding for the random sprite position. Yep, there's nothing else going on in there. I think we're good to go. Are we ready to go? But before we run this, you know when you have a little nagging doubt in the back of your mind, you think I've done something wrong, and I have. This Sprite Collision, I've got this wrong. So this command is correct. So we've got a variable called SC, and Sprite Coal will return not a 1 or a 0, it will return a -1 or a 0. So I double checked the AMOS manual. So Sprite Coal provides an easy method for checking to see if 2 or more sprites have collided on the screen. If this test is successful, Sprite Coal returns a value of -1, and if not, 0. So -1 is true, 0 is false, okay, and that's what we need to check for. Please note on here that I've said, or it says, to see if 2 or more sprites have collided. So effectively in the future you could actually expand this command to put in all the sprites that you're expecting it to collide with. Interesting, but for now it's going to be -1, everybody, -1. So don't forget to save. Left Amiga S to save. We'll check our code. There are no errors. And what we'll do, we've got stuff happening. So we've got our little animated character here. There he is. And see that? I hit him and it's moved the target sprite and it's incremented our counter there. So let's go and do that again. Bang, look at that. As soon as I touch it, it moves. Bang. And we go over here. It's a bit of a long walk to the other side of the screen, but as I hit it, bang, and we're away again. I'm going to tidy this code up, so our start position for our sprites is in a slightly different place, but we'll do that now. So let's go and so X value, I think that's right. Yeah, those are our X values. So what I want to do is change this. So let's maybe change that to 80. Change those and let's see where we go. That's better. That's better. Okay, so here's our little character. Nothing happens with the clock because we haven't got anything going on there. But I'm going to run across, tag, you're it. Yep, tagged, and each time he tags, the score increments. So the collision detection is working and it's moving. So we've pretty much got the foundation of a game starting here, because now the possibilities are a little bit more, you know, there are more possibilities, because I could put something on here like a timer, a countdown timer. So we've only got a certain amount of time to reach this player to tag him. And if that timer isn't long enough, then maybe the clock can come into play. If the clock appears on the screen, I could run for the clock and get some more time, and that will increase the time that I've got to actually run over and tag this player. And it's a case of see how many times you can tag it. You know, it's a very simple game. It's not, you know, it's not Doom. it's not going to set the world on fire, but it just shows the possibilities. So we have gone from I'm quite addicted to this actually. We have gone, let's end that. We have gone from just creating some images and putting them on the screen and moving them around, and now we've got collision detection, and now we've got a score, some sort of goal that we have to achieve, you know, in the program. And it's relatively simple. The code here is quite straightforward because, once again, AMOS is amazing and has these commands already baked in. So just a quick recap then. So our animation, don't forget anim, and you give it the channel number. Then in your brackets, you've got the image number, the time delay, and you can have as many images as you like in here. You can just keep going on this, and you can build up frame, and just have a number of animation frames all brought together, and, you know, running. We've got our collision detection, which is Sprite Coal, returns -1, people, -1 for true, and 0 for false. INC, increments a value in a variable, so that will just keep incrementing the score every time. And our random sprite procedure, which puts a random sprite on the screen. So going forward, we could actually parameterize that and have the clock appear in a random position each time as well. Something to think about. That's for next time. Don't forget, you can download this code from my website. There's a link. There'll be links showing you where to go. Right, and that, ladies and gentlemen, is pretty much it. Animated sprites, collision detection, the foundation for a game is unfolding or appearing before your very eyes, and you're coding it. Fantastic. Right, I'm pretty happy with that. Awesome. Just very quickly, if you didn't catch the last video and you haven't seen it, if you're wondering where these images are coming from, let me just quickly dive up into Edit Objects, and this will take us into the object editor, which you have seen, well, you may have seen before. And these are our images, okay? 1, 2, 3, and 4. So our animation on our little target character is here, and this is our player character. If I go into the clapperboard, I can select image 1 and image 2, and it loads it in, and down the bottom it's showing you what that animation will look like here. Okay, click on them to get rid of them, and if I bring in 3 and 4, there you go. That's our, and that's the speed that we're running at, okay? 1/10 of I thought 1/10 of a second, or was that 1/10 of a 50th of a second? I don't know. Someone will tell me in the comments down below. But that speed 10, that's what I've got it set at in the program. So there you go. And this is really useful because you can see what different speeds you're going to get if you change that value. And that's it. That's the object editor. That's where those animation frames are coming from. Hope that was a bit of an insight for you. Right. And that's it for another video. Thank you ever so much for watching. I'd also like to say a huge thank you to everyone who likes these videos, has subscribed to my channel, and has left some wonderful comments about these tutorial videos. Really, you are the inspiration which keeps me going and just keeps me creating these videos, because I really enjoy doing them, because I know people out there are getting a lot from them. They're not perfect. They're not ultra slick. There's probably better ways of doing this, but you know, if it gets you coding and you enjoy what you're doing and they have some form and functionality, I'm really happy. Okay, so if you want to find me online, there's my website. I'm on the Twitter, the Mastodon. I have a Ko-fi account as well. If you'd like to support my work, feel free, no obligation, but some of you do and it's just wonderful. Thank you so much for that. In the next video, we're probably going to start to wrap this program up and just kind of finish up, tidy it up a little bit. There's a couple of extra things I want to do, as I have already alluded to. So carry on enjoying coding in AMOS. Until the next video, take care of yourselves, and whatever you do, keep it retro.